Good morning, everyone. This is Sakid Ahmed over from Cambium Networks, welcoming everyone to a new year, 2019, and to this specific webinar that we're hosting for a lot of our customers from CTIconnect that recently purchased or are looking to deploy ePMP 3000. This will hopefully be a first of many webinars as we share and more information with our customer base and get feedback along the way. Rules of the webinar, pretty simple. If you want, you can ask questions in the chat window. I'm kind of administering this webinar myself, so it may take me a while to navigate things, but more or less, if you ask a question, we'll be able to respond. Just to check, is there anybody else from the co-organizer from CTI on the call?
Yes, hi Sakid, Bernie Vazenberg is here.
Hi guys, did you guys want to say anything as an opening statement? I wasn't sure if you guys were on.
Yeah, sure. Yeah, sure. Thanks, Sakid. I'll jump in. My name is Bernie Vazenberg. I am the Managing Director of Revenue for CTIconnect. I'd like to thank you guys for joining, and Happy New Year to everybody. Thank you, Sakid, for hosting the webinar. Sakid, in case nobody knows, is the Senior Director of Engineering for Cambium and will lead today's discussion for us. Just a couple of quick introductions, I guess, and background for CTI. In case you don't know, CTIconnect is an integration design equipment wholesaler for the wireless industry. Many of you guys know us as Convergence, but we, in the middle of last year or so, relaunched Convergence, and the new company name is now CTIconnect. So don't mix us up. We are now will be known as CTIconnect moving forward. You can check us out at CTIconnect.com, obviously. We're also pleased to have Garrett Kellner on the call. Garrett is the Managing Director of Operations for CTIconnect. And many of our account managers, Matt Kale, Jeff Broadwick, Mike Janikowski, James McKinley, Chris LaRoche, Joey, they're all on the phone. So if you have questions following the webinar, and if Sakid for some reason couldn't answer your question, which I highly doubt will be the case, please contact your account reps here at CTI. With that, I guess, Sakid, I'll hand it off to you, and I'll go on mute. And I can help you, Sakid, by the way, with any questions. I think I could see them popping through as well. So you can go on, and then maybe we'll save the questions for last as people just write your questions there, and I'll read them out loud to you, Sakid, at the end when you're ready, and we can go through the questions.
Yeah, thanks, Bernie. That's a good plan. Let's handle the questions at the end. So I also wanted to introduce Dmitry Moisev, who's also joined the call. He's a principal engineer on the ePMP program here at Cambium. So I'll go through things, but there are some cases where I'll pull Dmitry in and he'll update on some additional items along the way. So with that, let's go ahead and get started. Bernie, I was trying to pull a CTIconnect logo in that first slide, but didn't get around to it. Okay. So I'm assuming most of the audience here is quite familiar with ePMP, but I'm going to go ahead and do a quick little background real quick. The ePMP 3000 product, the idea behind this kind of manifested itself from our first two generation products, which is the ePMP 1000 and 2000. Those of you familiar or not absolutely familiar, a little background. We did the ePMP 1000. One of the key differentiations on it was the fact that we had GPS synchronization, so you were able to do frequency reuse. But to do the frequency reuse and the GPS synchronization, we did from the ground up a software solution that was a TDD frame structure, ripped away a lot of the Wi-Fi-like stuff that makes some of the other products not work so well in the industry in terms of frequency reuse, and created what I would like to say are probably the only affordable synchronized product in the marketplace. So 1000 came out almost in 2013-14 timeframe. You could add a lot of subscribers. It did really well in self-interference, but as well as consistent throughput, things like that. And you got 20 and 40 megahertz support out of it. Needless to say, all of these ePMP platforms, in order for us to keep the equipment costs down, we leveraged the economies of scale of Wi-Fi based chipsets. So the products are designed around that hardware, but fundamentally the software suite and things like the RF lineup, the filters, all of that is a complete different architecture that I'd like to say more like a carrier grade service provider market oriented hardware. So 1000 came out, and then we proceeded to look at the market and saw that we needed to solve the problem for external interference. And then ePMP 2000 was born. And with 2000, we added two main functionality on top of 1000. Obviously, the hardware is a bit different. The chipset inside, the memory, and all of that was a little different. But more or less, it is had a beam steering antenna in the uplink to handle the uplink interference. And then it also had a dynamic filter, which essentially a superhet receiver to help block out neighboring channel interference. So that was the 2000 story. I'll fast forward this. But naturally, with 1000, 2000, with self-interference, external interference, the question became, hey, how about the throughput increase? We really need something that gives us incremental throughput. Following the standard, we looked at 11AC. And our first reaction was when we looked at 11AC and you look at the evolution of the technology, you see a wave 1 and a wave 2 play. And that's dictated by the fact that when the standard changes and there's a lot of new stuff coming in, the ecosystem of partners and hardware vendors, you simply can't pack all of that in the first generation. So it split it in wave 1 and wave 2. In wave 1, the two main things that were offered was the higher channel bandwidth, 80 megahertz, and the higher modulation in 256 QAM. And a lot of vendors out there jumped on the wave 1 and yes, touted very high sector throughput or high point-to-point throughput, etc., using higher modulations and large channel sizes. We purposely ignored or chose to skip the wave 1 based products because 80 megahertz channel in a point-to-multipoint, it just doesn't seem a reasonable thing to get. For that matter, the higher modulations with their higher signal-to-noise ratio requirement also seemed a challenging scenario. So we waited for wave 2, and after a long wait and after a lot of development, we now have ePMP 3000, and the foundation of it is around this wave 2 platform, giving you multi-user MIMO. So what you see here on the slide deck is you see a picture of the AP with 4 connectors on top. Bottom right-hand corner, you see an antenna. But this is a pretty innovative solution at the end of the day. So we basically took everything we had in the 1000, 2000 from a software perspective, but now brought in the idea of multi-user MIMO, being able to do MIMO to 2 subscribers at the same time in the downlink, having the same support of uplink beam steering, using 2 overlapping 90-degree sector antennas to do beam forming to a single user or doing MIMO to 2 different subscribers. And with all that, you still have your higher modulation and use of channel bandwidth like 80 megahertz, naturally higher packets per second, et cetera, et cetera. And with that introduction, as we look at the features, I take a stance in explaining that when we talk about things like MIMO, higher channel bandwidth, 256 QAM, I categorize them as the things that are most likely, and least likely to achieve. And as you can see, least likely is getting that 80 megahertz type scenario. At the lowest common denominator, getting the MIMO, which also has its own requirements on angular separation and stuff that I will talk about in a second. But MIMO is something that you can achieve pretty quickly. If you are lucky that you have a subscriber that's relatively close by, you've got good RSSI, good gain, your signal-to-noise ratio or CINR is reasonable, you end up with a 256 QAM subscriber as well. So this is a good way to understand how we are positioning the feature set that's in the 3000. A little bit more detail on the value proposition. So MIMO being the key thing, and the picture on the right just essentially shows you the 2 subscribers getting the downlink transmission at the same time. You've got your 256.56 coding, even on 20 megahertz channel, which is something not available in some of the Wave 1 products. You've got the filtering like we have on the 2000. You also will be able to use that same beam steering antenna that you have on the 2000 today on the 3000 to take advantage of the uplink. You see the asterisk on it. The hardware support is there. We are just bringing in the software support through Q1 and hopefully release that by the end of the quarter to allow the beam steering antenna to function like it did in 2000. Some nifty things in addition to that that's important to highlight is the spectrum analyzer was one of the biggest sore topics in the history of 1000 and 2000 because you needed to do all sorts of Java security settings and turn off the radio, etc. But the 3000 AP does have a dedicated receiver chip, so you are able to run a real-time spectrum analyzer on the radio. And Dimitri was behind the scenes working on something in addition, that if you log in today and go to the spectrum analyzer, there's also a tool right below it that is, best way to describe it is if you're familiar with the original eDetect, it's essentially eDetect on steroids, because it is not just showing you interferers on your current channel, but it's across the spectrum. It will show you the MAC address, RSSI levels of other Wi-Fi based interferers that are showing up. So look at it as a tool to be used in conjunction with the real-time spectrum analyzer to give you a really good view, not only of what's happening in the air, but you can also actually now look at the signal levels of your own devices and derive the spectrum with the CDN, what we call the discovery tool, as well as the spectrum analyzer. A combination of those two, you can see where we stand in terms of the interference levels. A few other things that are very worthwhile noting is on the bottom right-hand side on the slide, you see like a 1, 2, and 3 scenario. This number 1 point has more to do with the backwards compatibility, which I'll touch on in a few minutes. But fundamentally, an ePMP 3000 AP speaking to a legacy subscriber speaks to it as if nothing has changed. The real purpose there is that we're trying to give you the benefit of avoiding a mass migration. So having a 11N based ePMP Force 200 or a Force 180 speaking to the 3000 AP, there's no sounding, there's nothing to do with MIMO. Having said that, point I want to highlight is that you do have 4 receive chains in the 3000 AP. So there is something called an MRC benefit, a maximum ratio combining benefit, that gives you a 3 dB additional uplink improvement, even when you're talking to a legacy subscriber. And there are a few other things under the hood with some improved coding rates and stuff that I won't get into, but those are some things that also will help overall performance that you will see as you experiment, as you deploy, and as you start putting customers on it. The second scenario on the bottom right-hand side of the slide is that even when you're not doing MIMO, that subscriber, that's a 11AC Wave 2 subscriber, is being served by both antennas, and therefore you're doing a beamforming towards that subscriber. So this question will come up later on, I'm sure, in the Q&A. Beamforming versus beam steering, the best way to think about this is in the 3000 AP, you're doing this beamforming in the downlink, and you're doing essentially beam steering for interference rejection in the uplink. And the beam steering is just like it was in 2000. You're essentially creating narrower listening areas. Instead of using the 90/120 degree sector to listen, you now choose the beam steering as appropriate to narrow the antenna beam pattern. So you're listening less to all the other interferers. In the beamforming mode, and essentially is taking the 2 overlapping 90 degree sectors where we're using phase shifting to talk to 2 subscribers at the same time. But when I don't have 2 subscribers, I can now combine that antenna gain towards a single subscriber and get that 3 dB additional gain. The last scenario is obviously the MIMO scenario, and that's the key highlight of 3000. A little bit on how does it work, give a little expectation scenario. What you see here is a actual deployment here in Illinois, Northern Illinois area, close to our office. And this is a 6 subscriber sector with Force 300s. And these are what you see in the azimuth, the A's, the degrees, -48, -43. Essentially, the fundamental way to think about this is that when you are deploying subscribers, there is a requirement for an azimuth delta. So you want certain degrees of separation between subscribers in order for us to successfully group them. And that requirement is that anywhere from 10 to 30 degrees separation between subscribers for us to be able to group them. And what you see in this scenario, and then I think I have some more slides that will elaborate on this, is that customer 1 and customer 2 are not groupable, but customer 3 is groupable to 5 or 6, and all because of the azimuth delta that we're able to do that. So let me just skip ahead. Not a terribly eyesore chart, but hopefully this kind of conveys it. What you see in the blue and the orange, a little bit under the hood explanation, but fundamental takeaway is, when you are having gain in one direction, you're essentially taking advantage of a deep null towards the other subscriber. This is how you're preventing both guys to listen to you at the same time and interfering with each other. But what you see in the green and the yellow is essentially that the green, in this case, customer 5, we chose as the primary SM. And you can do this in link test. You'll see the subscriber you choose, and it will show you the list of other subscribers that are groupable. So customer 5 ends up groupable with customer 4, 2, and 1, but not with 3 and 6. So let's remember the 5 versus 3 and 6. So 5 is down here, 3 is right here, and 6 is right there. So those guys are not groupable while the other guys are. Okay, moving ahead, a little bit of data from the same deployment. Top part of the table essentially shows the subscriber throughput in using a wireless link test, and you'll see the trial one, downlink versus uplink, average downlink, average uplink. Obviously, the MCS distribution. In some cases, there's some interference. There's MCS 9, MCS 8. And then as you go to a multi-user MIMO mode, the bottom part of the table, you see customer 5. You pick customer 5, and it's now grouping with 4, 2, or 1. So at any given time, we're taking 5, picking 4, and running a link test. And there, now you're seeing that your AP aggregate throughput just went to 173 meg. And then when you grouped it with the next subscriber, it's 179, 145. So it's an incremental jump in throughput at the AP. Things to keep in mind, and it's important, is that, from our perspective, from the product perspective, we are doing our job in grouping based on the azimuth metric, based on channel conditions, et cetera, et cetera. But ultimately, you have to have traffic. So the best way to measure the before and after scenario is to deploy the subscribers and to some extent not get overly concerned about how your subscribers are grouped or how close they are, but just do the deployment. Because one of the key advantages of 3000 in this case is its simplicity in the fact that it's only MIMO for 2 subscribers means that when you deploy 20, 30, 40, 50 subscribers, chances are we're going to be able to group a lot of different combinations, as opposed to systems with a much higher number of grouping capability where you need further density and closer proximity and things like that. So even though I showed the chart on the distribution, it's not something I would worry too much about. Just go with the deployment, put them out there, and then start playing with link tests, and you'll see how the radio system optimizes and does the grouping. But the last piece that I was mentioning is that in terms of seeing the net benefit from a before and after scenario, the best way to do that is really measuring your AP's throughput, which is essentially looking at your routers and if you use any type of traffic shaping type scenarios, just to see, hey, this AP used to consume X amount of megabits per second at busy hour. I put the 3000, I changed out some subscribers. I think I have MIMO. Am I consuming more? Are my users downloading more? because the net win here are two things. Number one, sector capacity goes up when it's able to do MIMO. Sector capacity goes up when some subscribers are getting higher modulation. And single subscriber packages can also be impacted, because now if you are able to get the higher modulations, your sector is not getting choked, you may be able to offer higher packages. But all in all, just like any new product, new technology, new understanding, you as a customer will have to experiment, have to deploy, and slowly understand how your network is behaving with the new stuff. And we're always there with you along the way, pushing out knowledge, information, et cetera, et cetera. Okay, the last piece, but probably on everybody's mind, is the backwards forwards compatibility. I think fundamentally what we want to convey to you is that we define forward compatibility as when an ePMP 2000 is having to talk to a Force 300 subscriber, which means the ePMP 2000 software has to be upgraded, Force 300 has to be upgraded, and that's forwards compatibility. Backwards compatibility means a 3000 talking to the legacy subscribers. While that may be the definition, fundamentally, the best way to take this away, talk about this, is everything talks to everything. A lot of questions will come up. Well, when is backwards compatibility available? It is available today, but we've chosen not to release the official backwards compatibility software images for the legacy subscribers just yet. We're working with some select customers to work out the kinks, and as we cook it, we'll make this available in a more broader scope. And the reason behind this is really simple. If you run a network with hundreds of customers today running reliably and well, you're about to go put a new AP, all these paying customers that are on your 90/120 degree sector now moves to a pure 90 degree sector, MIMO, et cetera, we want to make sure that there are no hiccups in your production network, in your paying customers' networks. So we're working with select customers to cook the backwards compatibility, forward compatibility, way more than we typically would for a brand new greenfield product. So give us a little bit of time. Your best interests are what we're trying to achieve, or drive towards. So we will test it and we will provide feedback at the forum, et cetera. And of course, through CTI, we'll make sure all that comes across. From a software release planning perspective, 4.3 is the official release that we programmed onto the radios and shipped it. That's what you should be receiving if you haven't received it already. But there is a 4.3.1 in true ePMP style. There's a lot of software releases, but by the time stuff shipped, we were already working on new things. So 4.3.1, there's a beta version already posted on our Cambium beta site that has additional bug fixes and things like that. But in 4.3, we kind of cut some of the scope down. We took away 40 and 80 megahertz support because we were seeing some issues. That's going to come back. There's some tweaks on the uplink side that we're still tinkering with. And then the backwards compatibility is under a very controlled beta. As we move forward, as we are talking primarily to a North America customer base, the DFS channels become a key question. All testing is pretty much done. If the government wasn't shut down, I think we would probably be in the lab retesting the slot. So now it looks like FCC DFS is probably going to be more of a Q1 play. I'm hoping that by the end of January, we can open this up and have the additional channels. A lot of work's going to continue throughout the first 6 months, whether it's requests and feedback from you or things that we've already planned, ideas around supporting other antennas for MIMO, downlink uplink ratios, et cetera, performance tweaks, improvements, bug fixes, and then key things like QoS, doing things with fast DFS, traffic shipping, et cetera, some placeholders that we're working through. Last but not least, a bit of a highlight on the hardware roadmap, but some of this may be interesting to the North America market, some may not. Top two are stuff we're shipping today. Immediately following, hopefully in a Q1 release, we're going to offer up a 2x2 Wave 2 access point, which will work with the RF element horns from day one. Really, the play there is not so much about MIMO, but more of a micro-pop solution, low density. You want to get the higher modulations. You throw one of these guys on with a twist port and a narrow horn antenna, you get the results you want. And then a couple of new subscribers, a 20 dBi flat panel. The reliability rating goes up a little bit on IP67, which is really not a WISP industry need, but there's going to be a variant in IP55. So if you think about the Force 190 product with the dish form factor, we're going down the path of a integrated panel, which it's got certain applications for it, but it may be a play for also the WISP market. And a 13 dBi, very short distance, small, tiny, you can hold it in one hand type device that we're also coming out with for different types of applications. Last but not least, we are going to have a horn antenna that will do MIMO, and what you see in that tiny picture is a prototype of that. That's what we call the dual horn, and the key thing that it's positioned as is a micro pop short distance play because the gain is not going to be huge, 9, 11 dBi. But if you wanted to light up a small area with a high density group of subscribers, you can put a 60 or a 90-degree horn on this attachment and serve that market. So that is the hardware roadmap, software roadmap, a little bit of insight on the product. And with that, I think my presentation ends here, and we can switch to Q&A. If Bernie, you wanted to drive that and see what has popped up.
Yes, I'd be happy to. Thank you, Sakid. Let's see. All right. Very good stuff. Sakid, here I am. Jeff Broadwick is here.
We're not taking questions from Jeff Broadwick.
All right, so you can't use the 2000 beamforming antenna with the 3000. Can you use the 2000 beamforming antenna with the 3000?
Yes, you can, but as I highlighted earlier, we have the hardware support, but we are the software support is still coming. So there will be support brought in a future release.
That was Jeff, by the way. Justin Wilson said, can you define sounding? Must have missed that somewhere in the beginning.
Dimitri, you want to take sounding? Define sounding? This is where the audio part gets tested. I made Dimitri a panelist. So, yeah, he's there.
See if I need to unmute him.
Yeah, I think that might be the case.
No, he's unmuted.
Yep, there you go. He's unmuted. Dimitri, you want to take Justin's question on sounding?
Yeah, because I already started.
He has already started answering.
Yeah. Okay. So, hey everyone on the call. Regarding sounding, so you can think about sounding as probing subscribers where they are. So you send a special packet to get the feedback from the subscriber. So you send a special packet, it measures all the subcarriers in the OFDM and it sends compressed feedback. So we can understand where this specific subscriber is located and how the phase shifts from different antenna elements are received by the subscriber. So we can do the multi-user MIMO to the subscriber. I hope it answers the question.
Okay, next question, Bernie.
Okay. Joseph Monroe asked, will the interference information, something we will be able to capture and look at as it changes channels and help us identify interference so we can talk to others in the area about them interfering?
Good question, Joseph. Good to see you on the webinar. Right. When you look at the interference information, so you've got the spectrum analyzer, right, which is raw information. But the thing that I was talking about is the graph that's right below the spectrum analyzer, which will show you MAC addresses of other devices that are more or less Wi-Fi based. So when you look up that MAC address, you'll know, hey, this is an Ubiquiti AP or Cambium AP or whatnot. And if you see energy levels really strong impacting your network, yes, you could go to that. The thing is, you won't know which direction it's coming from or anything like that, but you can suspect if it's high energy level interfering with you, then you have information there to go to that friendly or unfriendly neighbor and say, okay, this is what I'm seeing on my tower. We should coordinate. We should make an effort to sync up. I think that will help you having that information, definitely. Next one, Bernie.
Okay. Yep. Mitchell Block asks, please list any benefits you might see capacity-wise by just swapping the AP while you still have end clients, adding in the possibility for 10% TP reduction for overhead of AC talking to N.
Okay. Dimitri, why don't you take Mitchell's question?
Yeah, so first of all, I'm glad to have Mitchell on the call. He's our best client for last couple of months, helping us to make ePMP 3000 better. So there are multiple things that we bring on 11AC platform, which is different from 11N. So first of all, we enabled some of the, well, let's call them standard features from the Wi-Fi world, like short guard interval, LDPC, the new coding scheme that gives you better, like 3 dB of better sensitivity for the AP and subscribers as well. On the other side, we have 4 transmit and receive chains. And with these 4 receive chains, right now we can get so-called MRC gain on the receive side, so we can hear subscribers better. So just based on these radio features, ePMP 3000 will be better and you will have better link budget. On the other side, especially in the wider channels like 40 megahertz channel, we have way higher packet per second and way better CPU on the ePMP 3000. Even looking at ePMP 3000 and looking at the heatsink we have on the unit, you can tell that it probably has beefier CPU. And it does, so we can send way more packets per second. And it hit us a little bit on ePMP 2000 in 40 megahertz channel, and right now we don't have this limit. So in 40 megahertz for 11N subscribers, you will see definitely a benefit because of it.
Excellent. Thank you, Dimitri. Richard Bird asked, the last webinar, it was stated that the SNR of 34 to 36 dB was needed to reach MCS9 in a 20 megahertz channel. Would the current sector antenna that specifies 30 dB of front to back ratio limit the ability to reach MCS8 and 9 in a frequency reuse scenario?
Not necessarily. So there's lots of things. Front to back is just one of the components to achieve that SNR. It by itself does not necessarily completely remove your chances of getting the higher MCSs, because if you think about it, even in a back-to-back sector, if you're using frequency reuse, the energy and the front-to-back ratio assume certain separation of very minimal separation on the back-to-back. So if you have anything more than a couple of feet on a tower, you right away impact the energy coming from the back sector. Then the subscribers that are talking to that AP versus the other guy, they're both synchronized, but at the same time, you may not necessarily have the same levels of energy coming from the subscriber on the back sector. So there's other factors that start playing in, and the link budget that you have on the downlink with your subscribers, if they're up close, if you happen to have a dish at a kilometer and your overall RSSI is considerably higher, even if you get a little bit of energy coming from the back sector, it doesn't necessarily immediately take your chances of getting to MCS9. So unfortunately and fortunately, there's multiple factors here. A pure front to back is not a absolute slam dunk that says, oh, if I had the front to back, I'll always get MCS9, and vice versa. If I don't have the front to back, it doesn't necessarily mean you won't get it. Hope that helps. Next, Bernie.
Yes. John Whitford said, what is management Wi-Fi specified on the Force 300?
So John was paying attention to the slides. So management Wi-Fi is that on the Force 300 subscribers, one of the benefits of going to what we did with the Wave 2 chipset is it's a dual radio solution. So there is a second radio that today we have not enabled, but the desire and the roadmap plan is for us to enable that second radio. And when you first power up the system, you have access to that management radio. So maybe we'll make it a 2.4 that you can go up with your CN Archer or some other solution that you do yourself, access it, configure it, hit a button, it turns off that second radio. Now it becomes a spectrum analyzer function, and you walk away. So the whole idea is that when we enable this thing, the hardware is capable, but when we implement the solution, it becomes a tool for provisioning and installation.
Excellent. Justin is back and asked, since the APN sector has so many connectors, has there been any thought about adding cold shrink or something with the antennas or AP, whichever the cables are shipped with, to aid in weatherproofing? Can we see the connectors on the sector?
I don't think we have put much thought behind that, Justin. We kind of left it with that's an area that we feel our customers know best what to do in terms of weatherproofing from real world practice. But no, we have not looked into, I actually just walked over and looked at a sector antenna. No, we don't ship anything that helps with weatherproofing.
Yeah, and I might add, we can obviously help you at CTIconnect with the weatherproofing, so just contact your sales rep on that, your account manager as well. Richard Bird asked, did I understand correctly that sector antenna can do either MU-MIMO to 2 SMs or downlink beamform to 1 SM? I cannot do both. MU-MIMO with downlink beamforming to 2 SMs concurrently.
The answer to that, let me see if I follow the chain of the question. Okay, so the best way to think about it is this. If you have a 3000 AP and a sector antenna, and let's say you've got 10 subscribers in front of you, as you are talking to those subscribers, as there's data coming to them, the AP may say at one point, oh, I have data for that subscriber, but that subscriber is not groupable with anybody else. Therefore, that subscriber is going to get the downlink beamforming benefit and get served. But on the very next frame or next downlink cycle, there's data for 2 other subscribers, and the AP says, oh, I can group these 2, and it'll end up doing MIMO to those. So at any given time, it's a very dynamic environment based on the traffic that's coming and the RF condition, but the AP will end up doing beamforming to a single subscriber without doing MIMO, or at the very next second, it may be doing MIMO to 2 other subscribers. So it's a dynamic, and it is concurrently happening, but it all depends on the traffic profile and who is qualifying for downlink beamforming and who's qualifying for MIMO. Dimitri, if you want to add anything, please jump in if you want to clarify some more.
Oh, I believe we're good.
Okay.
Looks like a clarification question from Ken Miter. The Force 316, is that Q4 2019, Sakit, or is that supposedly for past Q4.
Yeah, sorry, 2018. That has been shipping, and
Yeah.
I think you guys have received some inventory already.
Correct. Yep. Okay. Very good. Britton Turner, Force 300 CSM timeframe. Both GPS and non-GPS models released at the same time? Question mark. Those are questions.
Yes. The desire is to release them both at the same time, and right now, a Q1 timeframe, probably all the way till the end of Q1. I'll just tell you that the hardware is more or less in good shape. I have samples that I really like. The mechanics have come out very nicely. Where we are is getting the whole ePMP 3000 software working in a 2x2 combination, and on that AP, that's kind of the task up front. What you'll probably see is somewhere in the early March timeframe, us publishing some type of beta that lets you guys try this, and we'll make some samples available. But right now, Q1, end of Q1, very hard tail end of Q1 is what I'm forecasting.
Excellent, thank you. Bob Henry, confirm or elaborate beam steering antenna release for Q1.
I would say that we're working towards a Q1. There's quite a bit of work to do on the software front, so I cannot, unfortunately, give you 100% confirmation or say that it's not going to be. Sorry, but I will know a little bit more with confidence as the quarter gets going.
Okay, strange question here. Will you be able to use the Mimosa N5 antenna with the ePMP 3000?
Only if you pay us money. For every Mimosa antenna. You didn't mention who asked that question, though, Bernie.
I know. I was trying to save them. Steve Needlelad.
That's okay. That's okay. So in the future, we will be updating our algorithms and stuff to offer support for third-party antennas. MIMO wise, it's optimized right now with our antenna, and there's a lot of engineering went into that. And I think what we'll end up doing is provide support for, third-party split sector. You want to put up 2 antennas, but as far as Mimosa's the Omni stuff, can't really say right now. We'll have to look at it. I don't see any reason why we wouldn't support it, but what is the drawback or what are the performance differences and all of that, that's something we'll have to take a look at.
Clear, thank you. Jacob Sherwood asked, with the DFS release, will all current channels on 2000 be available with the 3000, or will the channels be limited?
That's a good question. I don't know the answer at the top of my head without looking at all the channels. But I think there may be on the low end a channel or 2 that's different between the 2000 and 3000. I cannot tell you. I want to say the 3000 actually is better in the lower end of the channels, but we'll publish something on that channel by channel. But I will recommend strongly that you guys do look at the spec sheets and stuff, because even on the transmit power, it's a different platform. So even on the transmit power, there may be subtle differences between the 2 products. And that's the type of stuff you want to pay a lot of attention to as you try to do a backwards compatibility migration, antenna patterns, transmit powers, and things like that.
Excellent, thank you. Eric Rogers asked, what performance hits will the AP take on subscribers that are near line of sight? Is there a guesstimate per SF? Seems like a loaded one.
Ooh, yeah, it's a loaded one. It's a tough one. I hate to say this, but it's a trial and error thing. When you talk about near line of sight or non-line of sight for that matter, I mean, and Dimitri can chime in right after I'm done, but fundamentally there's a couple of factors. You hear about OFDMA versus OFDM with, OFDMA with subcarriers and subchannelization. You get some advantages. Now, these systems we're talking about are all OFDM, but it has some near line of sight, non-line of sight benefits. But fundamentally, if you got the you've got good signal levels and things like that, going through tree leaves or bouncing off of buildings, we've seen stuff work. As far as an estimate on what that would look like, it is so dependent on case-by-case basis that I simply can't or will not comment.
Yeah, it is mostly dependent in the rural scenarios. It's mostly dependent on the material of non-line of sight. So if we have trees, if we have hills, if we have other houses around, and if we have, I don't know, airports between us, so it all matters. So it really depends on the material more than anything. Yeah. So for the, as the kid says, try and see how it works.
Okay, Joshua Powell asks, any plans for 4x4 Omni?
Yes, there are plans. We're looking into it. Either we work with some third-party antenna vendors to see if there's specifications we can give them. Highly likely, we're probably not going to do one ourselves. But yes, let's just say loose plans, not anything concrete just yet.
Thank you. Josh Luthman asked, will that radio seeing noise with the Mac Wi-Fi, does that include AirMax or newer Prism radios, older M radios?
Yes, it will see everything that Ubiquiti has to offer in terms of their AirMax now or Prism, any of that stuff, or MikroTik, LigoWave, you name it. Anybody that is more or less doing something off of a Wi-Fi based chipset will pick up.
Excellent, thank you. Faisal, hi Faisal. Can you talk about signal to noise ratio in reference to modulation, and what secret sauce is available to deal with high noise floor and other interference mitigation?
Okay, so Faisal, I think this is a good question, but it does go back to a lot of the secret sauce of what ePMP is all about. So let's see if we can kind of highlight some of the key things. So first and foremost, we at Cambium have always talked about self-interference. So that's where your GPS sync stuff comes in. Transmit power control, that's another key benefit, right? You don't want to blast too strong, so we automatically tell the subscribers to lower their uplink power to reduce self-interference. Then there's things like the dynamic filter that I mentioned earlier. So if you imagine yourself putting it up in a congested tower and you got a bunch of other equipment from people you don't know or you don't like blasting away, you get some rejection because of the filtering. The beam steering and the uplink, that's another one. So now you got yourself a 90-degree sector. Imagine that as a giant listening ear. But if you put in the beam steering antenna, it starts to create these dynamic, narrow 20, 25-degree sectors to listen. And the AP is deciding for which subscriber when to use the sector antenna or when to use the beam steering and the uplink. So that's another element that's helping you with that. Things like a determinism in the protocol, right? It is doing a no contention. It doesn't care about anything else in the air. We will send traffic whenever we want to send traffic. The rate adapt mechanism, which has been optimized and tweaked over the years, going up and down on modulation to balance latency as well as throughput. A lot of thinking goes in there on how to handle the up and down of MCS states. The whole point to multipoint protocol, which leverages the concept of a GPF, which is a group pole frame. So imagine that we are in the AP and the subscribers have a one-to-many relationship. The AP is telling everybody exact precise time when they should transmit and receive. There are other systems that are out there that are more or less a one-to-one relationship. For every packet, there's an acknowledgement in the same transmission cycle, which eats up time, and as you add more subscribers, it deteriorates very dramatically. kind of went through the history of ePMP for you there, Faisal, but it's a lot of stuff that we've done over the years in the software that is all put together in this 3000 as well. Next.
Excellent. Michael and Verso, what is the required CI to maintain highest modulation level on the ePMP 3000?
We will share some published official numbers from our testing, but it's the MCS9 DIMA. I don't know if you have anything new, but if I remember correctly, I think we're looking at a 33 to 35 dB of C2I.
Yeah, it's closer to 35. And but the good thing is when we think about C2I, that in most cases we are not dealing with the constant interference. It doesn't have the 100% duty cycle. So even if you have other equipment working on the same frequency, usually it doesn't consume 100% of time. So interference, it pops up here and there during the time when somebody downloading or somebody uploading. So it means that you don't need this C2I all the time to get the MCS9. This is where our rate adapt jumps in. How smart and how fast we can shift gears from the higher MCS when we can do this to the lower MCS when there is interference in a certain period of time. And yeah, this is where our secret sauce comes in to get good numbers with the relatively high CTI.
Excellent, thank you. Bob Henry, can you provide information on where the 3000 stands relative to GPS antenna options, integrated or external?
So it's the same architecture as the 2000. First and foremost, you have an onboard receiver. The receiver itself has a little patch antenna, 4 to 5 dBi patch antenna. And then in the box, you're going to get the same hockey puck that we have on the 2000 that you can attach to that external connector. As soon as you attach, the receiver switches to the external antenna, and that has a higher gain and higher. It has higher gain. Those are the two main options. If you go beyond that, you can obviously go down the path of a Cambium accessory, the I can't remember, CN Pulse, I want to say, is what we call it. It's sort of a UGPS, which was our previous product. It sits high up on the tower, and you can bring sync in through the PoE port. You can also use a CMM5, which is also another accessory. So you got multiple options. It really has to do with are you seeing any issues? And if so, do you want to invest more money in an accessory that helps you get reliable sync? 90% of the time, the GPS puck that ships with it takes care of your GPS problems, and it's free. It's part of the AP that you purchased. We've heard reports at some points that, hey, with the puck and there's some LTE-like interference or the second harmonic from LTE causing some issues. On a lot of those cases, we recommended that you're actually better off not using the external higher gain POC and just relying on the lower gain GPS chip that's on the radio. And that has helped in those situations. But the short answer, I guess, to this question is that there are 3 or 4 different options for synchronization, both that comes on the radio as well as external ways.
All right, Jason Weaver asked if the products are available in Link Planner. I assume yes.
Not yet. We're putting some final touches on the Link Planner side. The whole MIMO prediction and all of that got a little bit more complicated, but we're working through that. I expect that Link Planner support will come in towards the end of Q1. Bernie, can we do like the last question since we're coming up on the hour?
Yes. Let me see if I could find a good one. Any ETA on elevated SMs working with the 3000?
You found a good one for sure. So we are. So Dimitri just gave me the good news yesterday that he's got Elevate working with the 3000, but he's got an issue with upgrade, which is a big issue. So we're fixing it. And Dima, what's the plan? Beta sometime in Q1 in a couple of weeks or a month or so?
Yeah, it will come up the same time as we have the release for original 11M ePMPs. So it will all come together.
Oh, you mean for backwards compatibility?
Yeah.
Okay. A time frame? Solid Q1?
Yeah, solid Q1, definitely.
Okay, so what Dimitri was referencing, gentlemen, is that when you do backwards compatibility, your ePMP 1000, 2000 subscribers need to be upgraded. And for that, we're going to publish the original tar.gz format file to download, while the 3000 stuff takes a different format. So when we publish that, we will also publish the packages that you would put on your elevated units.
Right.
And,
to work with ePMP 3000, all the 11M subscribers, ePMP 1000 subscribers or elevated subscribers, they have to use new language, let's call it 11AC language, new protocol, to work. So a new protocol is supported only on the new version of it, similar.
Right. Thank you. Okay.
All right. Excellent. Hey, Sakid, will you be able to make this available for us? Maybe we can post it on our website, send it out in our newsletter.
Yeah, it looks like I did hit the recording button for a second. I thought maybe I forgot, despite Jeff's multiple reminders. But yes, we'll publish this. We'll upload it somewhere so you guys can download, and we'll probably post it on our forum as well.
Excellent.
In fact, we'll post it on our forum, Bernie, and you guys can just link to it.
Okay. All right. Fair enough. Very good. Well, thank you, Sakid and Dimitri, for chiming in as well. Thanks for everybody for joining. I know we're still sort of on vacation time, or at least in our brains we are, but we are all excited about the new product. We are expecting a shipment. CTIconnect is expecting the first air shipment to arrive in the coming days. I think there's a little bit of a customs delay, but we should see them over the next week or so. And the container shipment is also on its way, and we have plenty on order to fulfill a lot of the demand that we've seen already for the ePMP 3000. We're excited to support and sell the new products.
All right. Thank you, CTI, for hosting this, and thanks to all of our customers that joined the webinar.
Yes, thank you all again. Appreciate it. Talk to everybody very soon, and Happy New Year.
Happy New Year. Bye-bye.